Welcome to this Eagle Vision training video. This is an instruction video for a Starch mold inspection. In this video I will explain how to use the Starch analysis settings. I have prepared our demo system for this specific Starch analysis setting explanation. So I will start inspection for the moment, so I can show you what I have prepared. So on screen I made one of the trays, I filled them with a few imprints and I made a few different defects within the tray. And I will go over each individual defect and how the specific analysis settings will affect if this will be rejected or accepted by the analysis. So right now you can see there's a little line on the left camera and there's a tiny little defect below that over here. And on the right I have made a bigger defect within the shapes that is rejecting right now, and also made a little bit of clutter on top of it. So I can show you how the system can eliminate the tiny little defects and how to filter out little cracks and stuff like that. If you want to access the analysis settings, you normally need to log in with your supervisor level password. Go to login with your supervisor level password, and then you can access the SMI analysis settings. If we go in here, the top one, LI analysis settings, that stands for label inspection analysis settings. These are the ones that I will discuss today. Over here you have a few settings. Largest defect within a pixel size, sum of all defects in a pixel size, the gray level threshold, and 2 erode dilate settings. When the system is comparing two different images with each other, it's going to look for the specific differences between the two. The first step that the inspection does is that it will take the gray level threshold and it will use it to determine if there's too much deviation compared to the pixels. This setting, the lower it is set, the more sensitive it is. So it allows a certain amount of deviation between the two pixels, and if there is too much deviation, so it will exceed this specific threshold, then one pixel in the image will be considered a bad one. So right now it's set at 25. This is a standard value. You can make it more sensitive by putting it lower, or you can make it more sensitive. So I will show you that right now. So if I go back to the image and I will zoom in, I will click on single image and will activate show analysis images. So over here you can see the little line in here, and right now it's accepting or rejecting it. And in the filter difference image you can see there's just a few tiny little red pixels. If I want to see this defect more reliable, I need to make the system more sensitive. So if I go to SMI analysis settings, I can, for example, lower the gray level threshold. And if I do this, if I, for example, put it at 10, which is very sensitive. If I go back, you can clearly see right now it's rejecting it every single time. And also in the bottom right, you can see that the red pixels are more visible. The defect is more clearly visible. If I make it even more sensitive, set the gray level threshold at 5, it becomes more and more sensitive. If I, for example, set the gray level threshold at 40, then probably it will not be seen anymore. So right now the defect is gone. You can still see a few little red pixels, and if you look at the numbers that come by, it just finds sometimes just a few pixels. But that's it. So I'll set it back at 25. So the gray level threshold works for one specific pixel. And there's a setting below that called erode and dilate settings. These settings are used to filter out the tiny little cracks and lines in the starch. This piece of the algorithm, it says that if it finds one specific pixel that is bad, so there's too much deviation, it's going to compare it with the neighboring pixels, up and left. And that pixel will only be considered a bad one when the neighboring pixel is also bad, and you can, with this you can set up the amount of how many neighboring pixels need to be bad. So for example, in this case, if you have a line of pixels going down, for example, there is only 2 pixels wide, and it can variate a little bit. With this setting, because it only finds one that is right next to it it will disable this one. So a tiny little line, horizontally or vertically, within the starch, it will not see that defect as a reject. So I can also disable this one. Let's put it at 0. Then it will disable this one. So right now, I previously adjusted the sensitivity settings, the gray level first, all the way to 40, and then I didn't see it anymore. So I changed the value, and right now the line is again clearly visible because it's not looking at the neighboring pixels. And also you can see the little defect below here. So the big defect line is right now visible. If I again a gray level threshold much lower, then you can also actually see that the little line over here is also visible. So this line, with a tiny little line, is right now also visible. So with this you can change the sensitivity. That's the primary part of the starch sensitivity. So normally the gray level threshold, 25, 20 is the standard minimum that I like to use. If you go much lower than that within the gray level threshold, the system is more prone to give a false rejections, or it can give some strange results because it becomes too sensitive. And normally within a starch inspection there's a lot of deviation between the trays, within the shapes and how much starch powder is on top of it, or tiny little cracks and lines. And if you make it too sensitive, then the system is more prone to give a wrong inspection result. The rodent dilate setting, again, because there's a lot of little cracks and lines in the starch most of the time, I prefer to put it at 1. You can also put it at 2, for example, but then it becomes way less sensitive. So I'll put it at 2 right now. So right now, almost doesn't see anything anymore. If I make the gray level threshold again way lower, so you can clearly see that it's filtering out a whole lot of stuff. So if I make it again, put it at 1, you can clearly see how much that difference it makes. So normally when the system finds a specific defect, it will show it on the top right in here. It will show you the amount of pixels that the system finds that have too much deviation after the gray level threshold and after our rodent dilate settings. So right now it's just finding, sometimes it's finding like 50, 100 pixels, it deviates a little bit. But sometimes it's accepting it, sometimes it's not rejecting it. But you see there, it finds constantly finding pixels. So the largest defect over here, that is the largest blob of bad pixels that have too much deviation that the system can find. And the sum of defect size, that are all the pixels that it can find in the entire image. So if I go back to the settings, and over here are 2 thresholds. So if the largest blob of pixels that has too much deviation, if it exceeds this specific value, then it will be a bad image. And then it will say, alright, it is rejected, it has too much deviation, this tray should not be filled with candy, and it should just pass through. Or overall there's too much deviation in the entire tray, it exceeds the value of 400 pixels, then it should also be rejected. So normally these are quite sensitive settings. These are the default settings. For example, if you make it more sensitive, you can make it more sensitive. If I put it at 10, for example, and I put this one at 200. If I go back again. So right now each individual time it's getting rejected and rejected and rejected because we make it more sensitive. And of course I can also make it less sensitive again. So for example, another setting that is commonly used is 250 pixels by 1000 pixels. Around 250 pixels is the shape of around 1 candy. So that's considered around 1 candy on average. See if I put it right now. So right now it's accepting it. And sometimes you can see that the sum is going up and going down. But right now it's accepting it most of the time. So over here I made a little line, tiny little defects on top of the starch. I want to go to the next image. So over here I made a large defect on the side wall within one of the walls of the candies. So Over here, one of the walls is completely missing, so if you would fill this one with candy, you will get like one very bad shape, which also, you don't want that. So this really is a reject in this case. So in this image, you can clearly see there's a big defect over here, and actually you can see the defect over here. But you also can see a lot of clutter on top of the starch. So I put a little starch powder on top of it. You can clearly see it in the image. But it doesn't really pop up within the filter difference image. So these settings, most of the stuff over here is actually filtered out by the gray level threshold and by the RO and dilate settings. If I go back again, and for example, if I turn off the RO and dilate settings, you clearly see how much the difference is. Pops up a little bit more. You can see that the dots over here are growing. You can see them, they are more visible. And if I make the gray level threshold much lower again, put it at 15 for example, you see that more and more stuff is popping up. So with this I can make it more sensitive. Put all the way at 10. So right now you can clearly see how much difference that makes. So in the top right again, you can see the same values again. So it's the largest defect right now it finds is 2,500 pixels or higher, and the sum of the effect is around 8,000 pixels, and it differs a little bit, between 5,000 and 8,000 pixels. So again, I can adjust the values. I can put it back again at the default. With this you can clearly see that it filters out most of the tiny little defects again, and then only the real big defect over here is found. The sensitivity settings, you can set them very sensitive for the starch mold inspection, but it's not always the correct course to set it up. Because if you're within the starch mold inspection, there's always a lot of deviation, and some lines are not always running very clean, or there's always a lot of deviation between the tray. You can make the system way too sensitive, and then you will lose tons of production, and then you will get like a very high reject rate of around 10%. Normally I'd advise to go around a reject rate of around 1%, then you're catching all the real large defects. So these values are these values over here that you see right now are for a standard normal line. Sometimes when you have a line that is causing more issues and there's a lot of disturbance, a lot of deviation between it, normally I would set the gray level threshold, for example, at 40. That will then only the real large defects within the trays are found. So when one or two candies or more are sticking together, big clumps, it will give out a reject signal. The specific settings in here, the LI analysis settings, these only contribute to the starch reject. The specific residual reject state for the SMI system is not done by these settings. So these settings, this will look at the gray level of the system, or it can also detect colors, but it will just look for the images, and it just will look if it's good or if it's bad, if there's too much deviation. This part of the system does not do the color analysis to check if there's too much deviation in the color. That is done by the other settings. This is the end of the Eagle Vision training video. Thank you for your attention. Please check out our entire product line and capabilities at eaglevision.nl.